So this question is taken from October-November 21, paper 3, variant 1. And this question is the second question of that paper. The first part is asking us to express a given trigonometric form into its harmonic format, where the value of r has to be positive and the value of alpha has to be in the first quadrant. We have to provide exact value of r and then give alpha correct to 2 decimal places. So to start with my first part, I know because I'm dealing with a harmonic identity, the value of r is always given by the square root of the numbers written over here. I'm going to do the square root of those numbers. So my r will be equal to square root of 5 square plus 3 square. So it is going to become 29 plus 9, which is 35 minus 1, which is 34. So square root of 34 becomes the value of r over here. And then to find the value of alpha, what I can do is I can know that along with the sin x, this will be r cos alpha. Along with the cos x, this is r sin alpha. So I can say that r sin alpha is equal to 3. And I also know r cos alpha is equals to 5. Let me call this as equation 1. Let me call this as equation 2. And now I just need to do equation 1 divided by equation 2 to get 10 alpha is equals to 3 over 5. And from here, I can say that alpha is equals to 10 inverse of 3 over 5. And therefore, the value of alpha, if I use my calci has to be in the radians mode, which is correct. Right now, my calci is in radians mode. And then alpha has to be in between, basically the first quadrant. So I just need to do 10 inverse of 3 by 5 and my answer will automatically be in the first quadrant. So 0.54 correct to 2 decimal places. And then you can conclude your answer stating that this implies r is equal to the exact format of r is square root of 34 and the value of alpha correct to 2 dp is 0.54. And we are done with the first part of this question. Let's move on to the second part. Second part is asking you to find the greatest and the least possible value of this term. Now, whenever they use the word hence, we know we need to use answers from the previous part or some information from the previous part. So clearly we can see that 5 sin x minus 3 cos x can be written in its harmonic format. So it's easier for us to find the value of the greatest and the least possible value if we know what is the square of this particular item. So let's go ahead and try to do this and see what we are going to get. So I know that 5 sin x minus 3 cos x the whole square can be written as r square sine square what? X minus alpha. So x minus 0.54. Now I need to find the greatest value of this and the least value of this. Let me just write r square as square root of 34 square, which is 34. Now I can say that greatest value is when I know my sine square x is greatest at 1, least as 0. So because the sine square x variation or sine square of anything variation is always in between 0 to 1. So the maximum value of the entire thing will be when 34 is multiplied by 1 and the minimum value will be when 34 is multiplied with 0, right? Because of course sine square x graph looks something like this. And if you are going to just stretch the graph in the y-axis with 34, I know that this is going to become 34 and this is going to be 0. So this is the quick visualization of what we are doing over here. So we can use this information and say that the greatest value is going to be 34 into 1, which is equals to 34, and the least value, it will be when sine square is going to be 0. 0 into 34 is 0, so that is how you are done with this solution.